Okay, in this video extra, I'm going to go over the second problem that you were asked to do after watching the video for one example, and then I'm going to go over a couple other practice problems. So this problem says, what proportion of students are willing to report cheating by other students? An SRS of 172 undergraduates at a large university, so SRS, that's our sample size, so that's 172. You witnessed 2 students cheating on a quiz. Do you go to the professor? Only 19 of the 172 students answered yes. So that means we're going to use that to calculate p hat. That's going to be 19 over 172. And then they want us to construct and interpret a 95% confidence interval. So we're looking for the z star value for a 95% confidence interval. So if we go to the bottom of our t-table, for a 95%, we're going to use a z star value of 1.96. So z star for this problem is going to be 1.96 for the 95% confidence interval. Next thing we're going to do is we're going to check our conditions. So the first condition is the random condition, and it does state an SRS. So for the random condition, SRS is stated. Then we are going to check the normal condition, which is the NP condition. So we're going to do N times P hat. So I actually need to calculate this. 19 divided by 172 is 0.11. So 172 times 0.11, that is 18.92. That's greater than or equal to 10, so that's good. And then we're going to do 172 times 1 minus 0.11. That's 153.08. And that's clearly greater than or equal to 10, so we're good for the normal condition. Lastly, the independent condition. We just have to think if 172 is less than 10% of the population, it is reasonable to assume that 172 is less than 10% of the population. So 172 is less than 10% of population. So you can say it's reasonable to assume 172 is less than 10% of the total number of undergraduates. Okay. Step 3, we're going to do our calculations. So to do our calculations, we're going to do p hat plus or minus the formula. So it's going to be z star times the standard deviation. So that's p hat times 1 minus p hat over n. So then we're just going to plug stuff in here. So we have 0.11 plus or minus 1.96 times the square root, 0.11, 1 minus 0.11 over n, which is 172. So we get a margin of error. So this whole part after the plus or minus sign is about 0.05. So it's 0.11 plus or minus 0.05. So we're going to subtract. That's 0.06, and then we're going to add. That's 0.16. So here's our confidence interval. Lastly, interpreting context, we're going to say we are 95% confident that the true proportion of undergrads willing to report cheating is between 0.06 and 0.16. All right, let's take a look at a couple multiple choice problems. So these are a little bit easier because you don't have to check all the conditions or anything. So this one says, Leandro wants to estimate the proportion of light bulbs that arrive broken upon shipment. He takes a random sample of 500 bulbs, finds that 25 have arrived unbroken. So we're going to use that to calculate p hat. So that's 25 out of the 500 were broken. So 25 divided by 500 is 0.05. So right away, I can already eliminate option C and option D since p hat goes first. And then the only difference between option A and option B is the critical value. So since we're calculating a 90% confidence interval, we're going to look at the bottom of our t-table. 90% confidence interval, we should be using a z-star value of 1.645. So in that case, the correct answer is going to be option A. This is the z-star value for a 95% confidence interval. All right, last one here. So this one, we are going to have to fully calculate out the margin of error. So for this one, I mean, even before doing any calculations, you should be able to eliminate option A and option B, because remember, this is a problem about proportions, and proportions always have to be a number between 0 and 1. So 78 is not a valid number for a p hat, but 0.52 would be. So we should already be able to eliminate A and B, which makes it so it's a 50-50 shot at guessing the correct answer. But we can go ahead and do the work and make sure we get the correct answer. So this part of the confidence interval, the second part here, this represents the margin of error. And remember that the margin of error is equal to z star times the standard deviation, which is going to be p hat times 1 minus p hat over n. Well, if we're calculating a 90% confidence level or confidence interval, we look at our table. 90% is 1.645. Actually, let me show it here. 1.645. So we're going to do 1.645 times. Now we need to figure out what p hat is. So here it says 78 of the 150 voted. So p hat is going to be 78 over 150. Or 78 over 150, which is 0.52, which we see here. So 0.52 times 1 minus 0.52, and our total sample size is 150. So when we put this in our calculator, 1.645 times the square root of 0.52, 1 minus 0.52 over 150, we get 0.067. So that means that C is the correct option here.